Now I am going to start the second chapter, acid, bases and salts. Acids are those substances which give H positive ion in aqueous solutions. Bases are those substances which give OH ion in aqueous solutions. When acid and bases react together, salts are formed. Now we are going to take up how to test acid and bases in the lab. In sample solution of HCl, if we add red litmus solution, there is no color change, and if we add blue litmus solution, it changes to red. Phenolphthalein indicator remains colorless in HCl solution, whereas methyl orange indicator gives pink color. In sulfuric acid also same observation you will see. Red litmus remains as it is, blue litmus solution changes to red, phenolphthalein remains colorless, methyl orange turns pink. In HNO3 there is no color change with red litmus. In blue litmus it turns red, phenolphthalein remains colorless and methyl orange turns pink. All these three acids are strong acid. Acetic acid is a weak acid, but here also red litmus solution will remain as it is, that is there is no color change. Blue litmus solution changes to red, phenolphthalein indicator remains colorless and methyl orange indicator turns pink. In bases, sodium hydroxide, red litmus solution turns blue, whereas blue litmus solution remains as it is. Phenolphthalein indicator turns pink and methyl orange indicator turns yellow. In calcium hydroxide solution, red litmus solution turns blue. Blue litmus solution remains as it is. Phenolphthalein indicator turns pink. Methyl orange indicator turns yellow. In potassium hydroxide, magnesium hydroxide and ammonium hydroxide, all of them are bases. In all the three, red litmus solution changes to blue. Blue litmus solution remains as it is, that is there is no change in color. Phenolphthalein indicator turns pink and methyl orange becomes yellow. It shows all acids turn blue litmus red, phenolphthalein remains colorless and methyl orange becomes pink, whereas all bases turn red litmus solution blue. There is no effect on blue litmus. Phenolphthalein indicator turns pink and methyl orange becomes yellow in color. Now we are going to demonstrate how do acids and bases react with metals. Metals react with acids to liberate hydrogen gas, and some metals react with base to liberate hydrogen gas. The second demonstration is the reaction between zinc granules and dilute hydrochloric acid or dilute sulfuric acid. Now we are going to take up reaction between metal and dilute acids. Metals react with dilute acids to liberate hydrogen gas. Let me give you an example. Zinc metal in solid state will react with dilute hydrochloric acid and result in the formation of zinc chloride aqueous plus hydrogen gas will be formed. Check this reaction is balanced or not. This reaction is not balanced. Reason, this side we have got 2 chlorine, this side there is 1 chlorine, so we multiply here with 2. Now check the equation is balanced. Yes, equation is balanced because all the atoms are equal on both sides. So here hydrogen gas is being evolved. Let's take up reaction of zinc with dilute sulfuric acid. Sulfuric acid also will react with zinc in the same manner and liberate hydrogen gas. Here zinc sulfate salt will be formed plus hydrogen gas will be evolved. Now this equation is balanced or not? This equation is already balanced because all the atoms are equal on both sides. Now tell me, when chemical reaction takes place, what are the possible observations?
Change in state.
Change in state is absolutely correct.
Change in color.
Change in color can also take place in chemical reactions.
Evolution of gas.
Yes, in some reactions evolution of gas takes place. And one more possibility is there.
Change in temperature.
Change in temperature is absolutely correct. So these are 4 changes which tell us that chemical reaction has taken place or not. Now we are going to take up reaction of metal with base. There are some metals which react with base to form salt and hydrogen gas. For example, zinc metal will react with sodium hydroxide to form sodium zincate, Na2ZnO2. Aqueous solution plus hydrogen gas will be formed. This equation is not balanced because sodium are 2 on this side. So if multiplied by 2, sodium hydroxide by 2, this equation will be balanced. This compound is sodium zincate. These metals which react with base, they are neither highly electropositive nor least electropositive. They are moderately electropositive in nature. Similarly, beryllium and aluminium also react with sodium hydroxide to form corresponding salts and hydrogen gas is evolved. Next demonstration will be how metals carbonates and metals hydrogen carbonates react with dilute acid. They give brisk effervescence due to carbon dioxide. Let's take up reaction of metal carbonates and metal hydrogen carbonates with acid. Let's take up example of sodium carbonate Na2CO3. This will react with HCl. It will result in the formation of NaCl plus water will be formed plus carbon dioxide gas will be evolved. To balance this, we have to multiply HCl by 2 and 2 NaCl plus water plus CO2. This carbon dioxide gas is evolved. If we react sodium hydrogen carbonate with HCl, similar reaction takes place. We get NaCl plus water plus carbon dioxide. This carbon dioxide is evolved in the form of brisk effervescence. If we want to test whether carbon dioxide is evolved or not, we have to pass the gas through lime water. What is lime water? Clear solution of calcium hydroxide in water is called lime water. And if we pass carbon dioxide gas through it, lime water will turn milky. Why lime water will turn milky? It will be due to the formation of calcium carbonate plus water will be formed. This is white precipitate. Now what will happen if we pass carbon dioxide in excess?
Milkiness disappears.
Why milkiness disappears?
Because calcium bicarbonate will be formed.
That is right. When we pass carbon dioxide gas in excess, what happens? Milkiness disappears. Why it disappears? It is due to the formation of calcium bicarbonate. Calcium bicarbonate is soluble in water or insoluble in water?
It's soluble in water.
It is soluble in water. That is the reason calcium hydrogen carbonate being soluble in water, that is why milkiness disappears. This is the test for carbon dioxide gas. Next demonstration is how do acids and bases react with each other. This reaction is called neutralization reaction and the products formed are salt and water. Now we are going to take up reaction of metallic oxides with acids. Metallic oxides react with acid to form salt and water. Now we are going to take reaction between copper oxide and hydrochloric acid. Copper oxide is black in color and basic in nature. Hydrochloric acid is colorless. We are taking one piece of copper oxide in a test tube. Now we are going to add hydrochloric acid to it. Observe the color change very carefully. Copper oxide reacts with hydrochloric acid and result in the formation of copper chloride and water. The color of copper chloride is green. Slowly the color is changing to green because copper chloride is green in color. See the color change. Yes, green color has been formed, and this is copper chloride and water is formed. This is neutralization reaction. Let's take up reaction between metallic oxide and dilute acid. Metallic oxide, this time we are taking copper oxide. Copper oxide is black in color. When we react it with HCl, dilute, tell me what will be formed?
Cuprous chloride will be formed.
Yes, copper chloride plus water will be formed. Copper chloride aqueous solution will be formed plus water will be formed. In copper chloride there are 2 chlorine atoms. So we have to multiply HCl by 2 so that reaction is balanced. What is the color of copper chloride?
Green.
Copper chloride is green in color. Another reaction we can take up is with manganese dioxide. Tell me, manganese dioxide is acidic, basic or neutral?
Basic.
It is basic in nature. MnO2 being basic in nature will react with dilute acid and it will result in the formation of manganese chloride MnCl2, but chlorine gas as well as water will be formed. Now this reaction is balanced because if I put 4 HCl, this side will be 2 water. There are 4 chlorine on this side, 4 chlorine on this side. Oxygen both sides are equal, that is 2. Manganese is also equal. This equation is balanced. Next reaction is reaction of non-metallic oxide with bases. For example, carbon dioxide reacts with calcium hydroxide to form white precipitate of calcium carbonate and water is formed. Now we are going to take up what do all acids and all bases have in common. Acids and bases all have H ions and OH ions, but in acids H ions are more than OH ions, whereas in bases OH ions are more than H ions. What happens to an acid or base in a water solution? Now we are going to take up what happens when acid and bases are dissolved in water. When acids are dissolved in water, they give H positive ion in aqueous solution. Whereas when bases are dissolved in water, they give OH ion in aqueous solutions. Now we are going to take up what happens when acids are dissolved in water. For example, HCl when dissolved in water, it will form H positive ion plus chloride ions. Similarly, if we take acetic acid is a weak acid. Now what is weak acid? Which does not completely dissociate into ions are called weak acid. It will form acetate ion plus H ion. Now what is the common in all acids when they are dissolved in water?
H plus ions are released.
Yes, all acids when dissolved in water release H positive ion. So the pH, what is pH? pH is the number which tells us whether the solution is acidic, basic or neutral. It also tells us whether the solution is strongly acidic, weakly acidic, strongly basic or weakly basic. If pH is less than 7, tell me solution will be acidic, basic or neutral?
Acidic.
Yes, when pH is less than 7, solution will be acidic. If pH is equal to 7, what is the nature of solution?
Neutral.
It is neutral. And if pH is greater than 7, then solution is?
Basic.
Yes, then solution is basic in nature. Now tell me, pH is equal to 1 is strongly acidic or weakly acidic?
Strongly acidic.
Yes, it is strongly acidic. As it is away from the 7, it will be strongly acidic. pH is equal to 6 is strongly acidic or weakly acidic?
Weakly acidic.
It is weakly acidic. Now we were taking pH equal to 8. pH equal to 8 is strongly basic or weakly basic?
Weak base.
It is weak base. Weak base. And pH equal to 13 is strongly basic or weakly basic?
Strong base.
It is a strong base. So with the help of pH we are able to find out strength of acids as well as bases. Let's take up sodium hydroxide or bases when dissolved in water. When bases are dissolved in water, they produce OH ion. For example, NaOH when dissolved in water, it will give you Na positive ion and OH negative ion. What will happen if I dissolve calcium hydroxide in water?
Similarly, OH ions are produced.
Yes, we will get calcium ion plus 2 OH ions are produced, because calcium hydroxide is CaOH twice, and all bases have pH more than 7.
Can you tell me what is the pH of blood?
Yes, pH of blood is 7.36 to 7.42. It is slightly basic in nature. Here we are showing you pH of some common substances on pH paper. It can also be tested with the help of universal indicator. Sodium hydroxide solution shows the pH 14. It is strongly basic. Bleaching powder or calcium hydroxide has got pH 13. This is also strong base. Soapy water which you observe is basic. Its pH is around 12. Ammonium hydroxide solution, which can be called as ammonia solution, it's a weak base and its pH is 11. Milk of magnesia, which we use as antacid, it's a weak base and its pH is 10. Baking soda solution, which is chemically sodium hydrogen carbonate, when we dissolve in water, its pH is 9. It is weakly basic in nature. Sea water, which contains dissolved salts in it, has got pH near to 8, whereas pure water, that is distilled water, has pH equal to 7. It is neutral. Urine is acidic in nature, rather weakly acidic in nature. It is pH is equal to 6. Black coffee is acidic in nature and its pH is equal to 5. Tomato juice is also acidic in nature. Its pH is approximately 4. Orange juice is also acidic in nature. Its pH is approximately equal to 3. Lemon juice has pH is equal to 2. Gastric acid, that is hydrochloric acid, is secreted in the gastric juice, is strongly acid. Its pH is between 1 and 2. And HCl has got 1 molar HCl has got pH is equal to 0. It is strongly acidic. Now we are going to take up how salts are formed. Salts are formed by the reaction of bases or basic oxides with acids or acidic oxides. For example, potassium sulfate is a salt. Its formula is K2SO4. It is formed by a base, potassium hydroxide, and acid, sulfuric acid. Similarly, sodium sulfate formula is Na2SO4. It is formed by the reaction of sodium oxide, which is a basic oxide, and reaction with acid, that is sulfuric acid. Calcium sulfate has formula CaSO4. It is formed by reaction of calcium hydroxide, that is CaOH twice, and H2SO4, that is sulfuric acid. Magnesium sulfate MgSO4 is formed by reaction of magnesium hydroxide, MgOH twice, and H2SO4. Copper sulfate is formed by reaction of copper hydroxide and sulfuric acid. Sodium chloride is formed by reaction of sodium hydroxide and hydrochloric acid. Sodium nitrate is formed by sodium hydroxide and nitric acid. Sodium carbonate can be formed by the reaction of sodium hydroxide with carbon dioxide. Ammonium chloride is a salt of ammonium hydroxide, that is NH4OH, and hydrochloric acid, that is HCl. Now we are going to show mixing of acid or base in water, and we will prove that it is an exothermic process, that is heat is evolved in this process. Now how do we take care while handling of acids? We should handle acid and bases very carefully. Always add acid to water and do not add water to acid. Reason being that when we add water to acid, the lot of heat is evolved, the container may break. And if we add acid to water, the reaction is less exothermic, slight amount of heat is evolved, which can be easily controlled by cooling continuously. Careless handling of acids can lead to danger. Here we are going to show the electrolysis of brine solution, that is saturated solution of sodium chloride. When you electrolyze sodium chloride aqueous solution at cathode, hydrogen gas is formed. This hydrogen gas is used as a fuel, margarine, ammonia for fertilizer. Hydrogen is also used for manufacture of hydrochloric acid, and it is used for cleaning steel, formation of ammonium chloride, medicine and cosmetics. At anode, chlorine gas will be formed. Chlorine gas is used for water treatment to get drinking water. It is used in swimming pools. It is used for making PVC, that is polyvinyl chloride. It is plastic, disinfectants and chlorofluorocarbons and pesticides. Pesticides are used to kill pests. Sodium hydroxide is also formed. It is used for degreasing metals, soaps and detergents, paper making and artificial fibers. Chlorine is also used in bleaching agent for household bleaches and also for making bleaching powder, which is used in bleaching textile materials. Let's take up electrolysis of brine solution. Now, what is brine solution? It is saturated solution of sodium chloride. Now, when we take aqueous solution of sodium chloride, which is saturated, and we pass electric current through it, what we get? We get sodium hydroxide aqueous solution plus hydrogen gas is formed plus chlorine gas is formed. Tell me why this process is called chlor-alkali process.
Because chlorine gas and sodium hydroxide is formed in this reaction.
That's right, we call it chlor-alkali process because chlorine gas is being formed and sodium hydroxide is formed. Why sodium hydroxide is called alkali?
Because it's alkaline in nature.
No, sodium hydroxide is base, and those bases which are soluble in water are called alkalis, and those bases which are not soluble in water, they are called bases but not alkalis. So soluble bases are called alkalis. So we call it chlor-alkali process.
Sir, can you tell me which gas is liberated at cathode and which at anode?
Yes, that is a good question. Hydrogen gas will be liberated at cathode and chlorine gas will be obtained at anode. Now, why hydrogen gas will be obtained at cathode? Because H positive ion will gain electron to form hydrogen gas, and this will gain of electron takes place at cathode, which is a negative electrode. At anode, loss of electron takes place, means 2 chloride ion will lose 2 electrons and chlorine gas will be formed. So chlorine gas is liberated at anode. Let's take up manufacture of bleaching powder. Now first tell me, what is bleaching powder chemically?
Calcium oxychloride.
Calcium oxychloride is absolutely correct. So bleaching powder is CaOCl2. How to prepare bleaching powder? What we take? We take dry slaked lime. Dry is very important because if we take aqueous solution, then reaction will not take place. When you take solid calcium hydroxide, that is slaked lime, and pass chlorine gas, the product formed will be calcium oxychloride, which is solid, that is bleaching powder plus water is formed. Now let's take up uses of bleaching powder. The uses of bleaching powder, tell me what are the uses of bleaching powder?
It is used as bleaching agent in paper and textile industries.
That is absolutely correct. It is used as bleaching agent in textile and paper industry. Any other use?
It can be used as disinfectant.
That's right. It can be used as disinfectant. What is disinfectant? Disinfectant kills microorganisms or germs present in drinking water. So the drinking water which you get is chlorinated, or a calculated amount of bleaching powder is added. Tell me, can we use it as a oxidizing agent?
Yes.
Yes, it can be used as oxidizing agent. In many of the reactions in carbon and compounds, bleaching powder is used as oxidizing agent. There is another use of bleaching powder.
It can be used as chlorinating agent.
Absolutely correct. It is used as chlorinating agent in the formation of chloroform or carbon tetrachloride. These are the uses of bleaching powder. Let's take up baking soda. How we can prepare baking soda? By the way, what is the baking soda?
Ammonium chloride.
No, it is sodium hydrogen carbonate. Baking soda is sodium hydrogen carbonate. Now how do we prepare it? For preparation of baking soda, we take brine solution. Brine solution is sodium chloride solution. We pass carbon dioxide gas plus we pass ammonia gas. Means carbon dioxide is passed through ammonical brine solution. It results in the formation of sodium hydrogen carbonate plus NH4Cl is formed. This is sodium hydrogen carbonate, which is also called baking soda. Now tell me, what is baking powder? Any one of you know what is baking powder?
Sodium carbonate.
It is mixture of sodium hydrogen carbonate plus tartaric acid. Now question is, why do we need to add tartaric acid? Tartaric acid, sodium bicarbonate or sodium hydrogen carbonate, when it is heated, it results in the formation of sodium carbonate plus carbon dioxide plus water is formed. This sodium carbonate is bitter in taste, and that will make your biscuits or cakes bitter in taste. To neutralize the bitter taste of sodium carbonate, tartaric acid is added. That is the role of tartaric acid in baking powder. Now we are going to take up uses of baking powder. Tell me, what are the uses of baking powder?
It can be used as an antacid.
Yes, one of the uses, it can be used as antacid. What is meant by antacid? It can neutralize hyperacidity in stomach. Next is, it can be used in cakes, breads, and that will make the cake and bread soft. Biscuits also it can be used. It can be used as fire extinguisher. How it can be used in fire extinguisher? In fire extinguishers, sodium bicarbonate will react with sulfuric acid and liberate carbon dioxide, and carbon dioxide acts as a fire extinguisher. Any other use of baking soda? It can be used in normal kitchen for the various cooking where baking soda is used. For example, the chola bhatura which you make, that also we add baking soda, by which it becomes fluffy. Let's take up manufacture of washing soda. Now what is washing soda? Washing soda is Na2CO3 into 10H2O. These water molecules are water of crystallization. When you crystallize sodium carbonate in aqueous solution, it absorbs 10 molecules of water and results in the formation of washing soda. Tell me, what are the uses of washing soda?
It can be used as cleaning agent.
Yes, one of the important uses, it is used as cleaning agent. What is another use of washing soda?
Removal of permanent hardness of water.
Yes, it can remove hardness of water. Actually, it can remove both temporary as well as permanent hardness of water. It is also used in manufacture of glass and cement. So glass and cement industry is also based on washing soda. Washing soda is also mixed with soap as a cleaning agent. So in manufacture of soap also washing soda can be used. Now we are going to take up how to prepare plaster of Paris. First we want to know what is plaster of Paris. It is calcium sulfate hemihydrate. Hemihydrate means half molecule of water of crystallization. It is prepared from gypsum. Gypsum is CaSO4 into 2H2O, and it has to be heated at a specific temperature, that is 373 Kelvin. it will result in the formation of calcium sulfate dot half H2O plus 3/2 water will be separated, and this is POP or plaster of Paris. Plaster of Paris has got a special property that when we mix it with water, it results in the formation of gypsum again. That is, it becomes hard, and this property is used for various purposes. Plaster of Paris is used in making good quality chalks. Plaster of Paris is used for making statues. Plaster of Paris is used for plastering fractured bones. Plastering fractured bones also plaster of Paris is used. And during whitewashing, whenever there are gaps on the walls, they are also filled with plaster of Paris. Filling gaps. And the jewelry designs are also made with the help of molds which are made up of plaster of Paris. So it's a very important chemical which is used in our daily life. Now we are going to show you the crystals of blue vitriol, gypsum. Blue vitriol is copper sulfate into 5H2O. This 5H2O is water of crystallization. Gypsum is calcium sulfate into 2H2O. It is used for manufacture of cement. Green vitriol is FeSO4 into 7H2O. Green vitriol is also called folic acid. It is used as a medicine for anemic patients. Let's take up effect of heat on hydrated salt. For a first example of hydrated salt I have taken is copper sulfate into 5H2O. It is also called blue vitriol. When it is heated, it results in the formation of copper sulfate, which is also called anhydrous copper sulfate. The color of anhydrous copper sulfate is dirty white, plus 5 water molecules get separated. These water molecules are called water of crystallization because these water molecules are associated with crystals of copper sulfate. Similarly, we have got FeSO4 into 7H2O. This hydrated salt is called green vitriol. Green vitriol, when heated, it results in the formation of FeSO4, which is called anhydrous ferrous sulfate, plus 7 water gets separated. The color of FeSO4 solid is also changed. It becomes dirty white in color. So these reactions show that the water of crystallization is present in some salts, and these salts are called hydrated salts. And on heating, water molecules get separated, and on cooling we'll get liquid water. These are chemical compounds, their common names and chemical formula. The first one is copper sulfate. We can call it hydrated copper sulfate. Its common name is blue vitriol. Formula is CuSO4 into 5H2O. Ferrous sulfate is called green vitriol. Formula is FeSO4 into 7H2O. Zinc sulfate is called white vitriol. It is ZnSO4 into 7H2O. Calcium sulfate is also called gypsum. It is CaSO4.2H2O. Sodium sulfate is called global salt. Its formula is Na2SO4.10H2O. Magnesium sulfate is popularly called Epsom salt. It contains 7 water molecules which are water of crystallization. So the formula is MgSO4 into 7H2O. Sodium carbonate is also called washing soda. It contains Na2CO3 and 10H2O. Sodium carbonate decahydrates. All these salts are hydrated salt and contain water of crystallization.